Welcome everybody. I'm going to explain this curve, which is very important, and this curve is about the pH. And we have to divide these equations into different parts, and the first part here is analyzing it. So as we can see here, it says that you have a base, which is sodium hydroxide. You have a concentration of this is added to this amount of HBr. So as we can see from this equation, we have reaction between NaOH, okay, plus HBr, okay, which is acid-base reaction and gives for sure salt in ABr and water, okay. So from these reactions, we can deduce that the ratio between HBr and sodium is 1:1 ratio, okay. And it says that we have the concentration 0.14 sodium hydroxide and the volume is unknown, we don't know it. But for the HBr, we have 0.1, the same concentration as NaOH, and 25 cubic centimeter. So there is a rule says you have to multiply the concentration and volume over the ratio, okay? This is for base. It must be equal to the concentration times the volume over the number of ratio, or let's say the ratio number of acid. Since we have the same ratio, which is 1:1, so the way we cancel these each other, as we can see, and then we can say sodium hydroxide is 0.1 times V, which is unknown to me, equals to 25 times 0.1. And if you do some math, you can cancel this with this, and then you notice that the volume of NaOH that leads to make neutralization is 25. The 25 here indicates that you have to draw the vertical line, okay? This is for a vertical line in the graph, which is very nice. The second information that you have to put in your mind, if you look at the HBr, it is a strong acid, okay? And we just remember that from the chapter of hydrogen halides, we started with HCl, which is a strong acid, and the stronger one is then HCl is HBr, and then it's followed by HI. So all of these are strong acids. The strong acids have a pH of less than 2. I mean, 1 maybe it works nice. On the other hand, we have NaOH, and you know there's no need to talk about this. This is a strong base, and it has a pH of greater than 12. So all of these details are given to me. I have the pHs, okay, and the volume at the equivalence point. All right. Another information is to put in our mind. It says that the sodium hydroxide is added, which means that the sodium hydroxide is in the puree and the HBr is in the flask, which means that we have the pH meter in here. So the pH meter starts to read from below 2, or let's say 1. So let's start raising all of this stuff in here. And as we can see, we have the vertical line. I'm going to use my ruler, and we're going to draw the vertical line, which is which is on 25, since we need to write it. I just want to write it the proper way. Okay, so we have, okay, right here, and it says that we have pH meter that starts reading from pH which is less than 2, and suppose that we started from here, so we can say here, which is 1, since it's a strong acid. We have this one here, and then we notice that the pH, the final pH must be greater than 12, and we just like moving like this, and here. We can say that the pH here is greater than 12, and the pH for HBr is below 10. Once this reaction is between acid and base, then the pH must be 7. So we take the half distance, and here the vertical line, this is the vertical line, we take the half distance and must be equal to 7. And actually it makes sense in this case. So let's go to the second graph, and actually we're gonna do the same thing, but we have a little bit difference. We have reaction between ammonia, and we have the same concentration as the one above and the same concentration of HBr. The only difference here, let's say in this case, is NH3, which is a weak base. And the weak base has a pH that is below 12. And I think we mostly use, let's say 8 is good, 9 is good. It's considered as weak base. Since they have like NH3 plus HBr, you will have NH4 Br In this case, you have the ratio, which is 1-to-1 ratio. So we'll do the same repetition in here, which is the same idea. And the volume becomes 25. The volume is 25 since we have the same concentration, 1V for NH3 equals to 0.1 times 25. We'll do the same thing that was done here. And then we have the volume of NH3 equals to 25. All right, so I want to erase all of this stuff in here and then write it again. I will draw the vertical line, which is around 5 here, just like a hand for me. And then I will start with the pH, which is HBr, which is below 2. We drew the same thing here. We're going to erase it. But put in your mind, we have to reach to number 8 or 9. It's okay. So we can say, let's say 9 here. Yeah, we can draw it like this. All right. Okay, so this is the pH for my curve. In your examinations, they will look at, did you start at below 2 for both curves? Do you have a vertical line at 25 in this case? Did you end at the pH, which is below 12? And all of these answers are done.